Good morning. Nice to see you here. Welcome to Potsdam and welcome to the GGOS Days 2024. I think we have some new faces here and also online. We should be here around 65 people. Probably they are coming later. And we have about 285 online participants registered. Let's see if all of them will participate or not. But I try to include in this welcome some basics about GGOS and why we are here today. Okay, let's see. GGOS is a global observing system. And what is a global observing system? This is a set of many individual terrestrial and space-based observing networks on sensors. And then these networks of sensors collect data essential for monitoring specific characteristics of the Earth. Probably the most known observing system is the Global Climate Observing System. And this system observes physical, chemical, and biological properties of the climate system. We have also the Global Ocean Observing System, and this system observes some characteristics of the oceans. The Global Ocean Observing System contributes to the climate system, but also observes other characteristics not covered by the climate system. And we have the Global Geodetic Observing System. And the key word here is geodetic. So GGOS observes the time-varying gravity field, geometry, and rotation of the Earth. These are the main objectives of geodesy with respect to precise and long-term stable geodetic reference frames. And the reference frames are also a particular characteristic of GGOS because the other two observing systems don't take care about the reference frames. How it does work? So in geodesy, we determine different parameters describing the geometry and kinematics of the Earth, the rotation and orientation of the Earth, and the gravity field. For that, we use different observations based in space techniques and also terrestrial techniques. With the space techniques, we can do a global monitoring of the Earth. With the terrestrial techniques, we can increase resolution, spatial resolution of the signals or observations that cannot be captured by the satellite observations. But the link between observations and the geodetic parameters are necessarily precise reference frames, precise satellite orbits, and consistent standards. The geodetic parameters reflect changes in their system, and changes in their system or any of its components are affecting our observation. So we need to know very well this relationship in order to determine our parameters, the geodetic parameters, with the accuracies we want to do it. The main challenges today are a combination of all existing geodetic techniques. Today, most of them are analyzed in separate ways. We need to do an integrated analysis of all geodetic parameters. This is useful to determine the gravity field here, and to determine the geometry of the Earth here. And we need to improve the integrated analysis of these parameters, and also we need to improve the modeling of the interaction between the different components of the Earth system. How can we go from the observations to the Earth system modeling? We need, of course, the measurements. They are the input for our analysis. We need consistent analysis, and this means we need to use consistent standards and reference frames to analyze the geodetic observation. We need integration and combination of the different techniques in order to identify geodetic or geophysical signals to distinguish these signals from possible biases in the different observation techniques. We need modeling and interpretation, and this means we need to identify if the changes we are measuring with geodesy to which Earth system signal corresponds. So that we can say the variations in our results are representing the variations of this component of the Earth system. And finally, we need to communicate our results because we can do a very amazing research. And if we don't provide the results of this research, we are not doing at the end nothing because every action of the human being is to improve the quality of life of the human being. So we need to communicate and provide our results to society and other sciences. This means that a global observing system is not only an observing infrastructure. We need data analysis, we need data banks, we need data providers. We need to improve our analysis through research, and we need to offer our results to the community. And all of this based on the different global reference frames. You can see there the four main now global reference frames. For the celestial reference frame, the terrestrial reference frame, the reference frame for physical heights, and the reference frame for terrestrial gravimetry. So, all these components or this structure is possible thanks to the International Association of Geodesy. The IEG was created more than 160 years ago, before special agencies, before national mapping agencies. And the continuous work framed by the IEG led us to this today infrastructure. We have different commissions, intercommission committees, and projects dedicated to address key scientific uses. But we have also the IEG services, which facilitate the global coordination of different geodetic activities. And the IEG services are so important because they they translate the science research or the research results into operational services. So they are doing this translation from the, let's say, the desk in bureau, the computer in the office, to the society. Just to show an example, this is the International Union of Geodesy and Geophysics. This is the parent organization of the IAG, but also other 7 associations dedicated to different Earth system components. And I will not go into the details. I will just only show, for instance, here in Cryosphere, we have one service. Okay. Here in Japso Ocean, we have 2 services. And here in Ayaga, we have 1 service. And you can see here in the IEG, we have 12 services. And this makes the IEG really a special association. Based on this infrastructure, about 25 years ago, some IEG officers, all colleagues of us, had the vision of using this work inside the IEG to serve science and society far beyond the traditional task of mapping the Earth's surface. So when we start learning what geodesy is, the objective was measuring and mapping the Earth's surface. But today, we can provide more than these basic geodetic products. So we can go to a level of consistent modeling and interpretation of Earth system processes and interactions. And the idea was to provide an integrated observing system and not many individual technique-dependent products. In order to put all these elements and ideas and visions together, 4 main entities were established. And I call this the organizational element facing specific building blocks of GGOS. A GGOS Bureau network and observations to follow the global geodetic infrastructure. A GGOS Bureau of Products and Standards, aimed at the standardization, integration, and optimization of geodetic products. A GGOS Coordinating Office, which is responsible for outreach, communication, and external relations. And we have also the GGOS affiliates that are national or regional geodesy-related organizations that promote geodetic activities in their countries and regions. And the GGOS affiliates are very, very important because the geodetic infrastructure belongs to national agencies. Also, GGOS or IAG don't belong stations and are not able to install stations or buy a VLBI antenna. This is done by national agencies. In addition to these operational elements, we have also the so-called focus areas. The GGOS focus areas serve as incubators of new research topics or interdisciplinary research. And the objective of them is to see how operational products can be established to address scientific uses. Today we have three focus areas: geodetic space water research, geohazards monitoring, and artificial intelligence for geodesy. If we put all this together, you can see here the different components of the Bureau of Networks and Observations. We have some committees there, we have representations of all services there, and some working groups. The same with the GGOS Bureau of Products and Standards. We have extended committees, working groups, representatives of the services. The focus areas are here. The coordinating office, in addition to ensure the connection with the outside world, is also acting as a secretariat of a GGOS. We have the GGOS affiliates here, and another important element is the GGOS Science Panel. They are experts in different geoscience topics who provide support to relevant theoretical uses in GGOS. And we have the GGOS Governing Board. The GGOS Governing Board defines the strategic way for GGOS. And it is composed from representatives from all IGG components. So we have commissions, services, intercommission committees, and all IGG components are represented in this governing board. I put some numbers here to show you how many colleagues are involved in these different components. It's probably that some colleagues are participating in different bodies, but it is just to show how many people are behind GGOS. And what we are doing today or tomorrow here is to hear the reports from all these colleagues working for GGOS. This is a business meeting. We will not talk about accuracies or improvement of models, of geophysical models, no. We will hear a report of activities from these colleagues. We classify the agenda of the GGOS Days in different topics, a little bit oriented to the building blocks of GGOS, updates on the global geodetic infrastructure, geodetic products, networking with external stakeholders, and also advances of the GGOS focus areas. And I would like to thank my colleagues in the executive committee of GGOS for setting this agenda. And this is the welcome. I would like to give some indications related to this meeting. And the first one is we have to leave today the building before 18 p.m. or 18 p.m., 6 p.m., or we will have to sleep here. We want to make a picture at 12:30 to the lunch break, but it's possible that it is raining. So if we have nice weather before the coffee break, we can make the picture before the coffee break. And this will be Upstairs, there is a nice roof with a nice view over the city, so we can make the photo there. And we will have a self-paid dinner this afternoon in a nice Italian restaurant close to the venue. We have still places, so if someone wants to join, please let us know. And I would like to give some special thanks to the people who made this meeting possible. First of all, GFZ for hosting the meeting and Robert Heinkelman for offering to host the GGOS Days here in name of the GFZ. And these four beautiful persons, Kirsten, Natalia, Sasha, and Alex, because they are taking care of the logistical organization. So when you are drinking a coffee, please think this is possible thanks to our nice colleague in there. And I would like also thank the Austrian Federal Office of Meteorology and Surveying and also my university for the support they gave us to work on GGOS. So this is all what I want to say now.